Good evening, everyone. We're so happy to see you, and so grateful for you guys to take some time and join us and listen to our discussion on cloud. It's so nice to be here in Cebu.
Yes, it is.
This your first time?
This is my first time here in Cebu, and I really enjoy it. And I'm so excited to see the other places here in Cebu.
Yeah, first thing we did upon coming here was to grab a bite of Cebu lechon with the sinuglao. The best
Wow.
ever, right? So, have you tried Cebu lechon, Wendell?
Not yet, but I will. I
You
will.
missed one half of your life.
Okay.
But
But
if
you might
eat
miss
too
half
much
of your
it-
life as well.
if you eat too much of it, you might end it.
You'll only have
Earlier.
half of your life, right?
Yeah. Okay.
So Dan, a while ago, that speaker, the guy who looked like Matthew Broderick, you saw him?
Yeah.
He was convincing us to go to the cloud.
Oh.
And you know what? I'm an IT developer lead as well. No? In my project, I lead the IT development in my project. And you know what? I tried that website, official wedding. It works. So I'm kind of convinced to go to the cloud.
Yeah, and you have your wedding website.
Yes, I'll also have my own wedding website posted if ever I get wed.
Wow.
However, as an IT development lead, I'm still scared. I'm still scared to go full blast. And I'm thinking of going on a private cloud. I'm not yet ready for a public cloud, just a private cloud.
All right.
But even then, as a private cloud, using a private cloud, I still have my worries. You know what? My worry is this. If I use a private cloud, you know what? I put all my applications in my private cloud for my company. My question is, what will happen if one day I have a new application and there's no more space in my cloud, in my private cloud? How would you advise me as my IT infrastructure lead?
Right. So I think the most common question is the cloud scalable?
Yes.
So traditionally, when we talk about scalability, we talk about buying new hardwares, right? So that would mean new equipments in our inventory, and that would mean more space in our data center, more power consumptions, probably more staffing to manage those servers and all. So the question is, how do you scale up and scale down in a cost-efficient and cost-effective manner?
Yes, that's my question.
Right. So on this discussion, we'll discuss a private cloud method or offering, right? So how private cloud can efficiently deliver infrastructure services, right? So it enables IT department to consolidate the servers and storage, lessen the server footprint, provide advantages in cost, quality of service. I think this is a very good point, providing on-demand access to infrastructure in a self-service manner, and provide elasticity, right? So you can upscale and downscale quickly and responsively, and also in a cost-efficient manner. So we're going to talk about several consolidation models. So we're going to talk about server consolidation, so reducing the number of physical servers, footprint in your infrastructure. We'll talk about how to consolidate your storage in a common network storage infrastructure. And probably the third point is to use common cluster environment. So we'll touch a bit on Real Application Cluster, which is a product of Oracle. And also database consolidation, using a common database for data repository.
Wow, that seems to be all high tech, Very, a lot of it are new to me. But then, you know what? You have to understand, my development team, who among you are development team members? Raise your hands. All right, you know what I'm talking about. I have 3 development teams, and they're crazy. You know what? You know why? Because I'm not talking about you're crazy, but I'm saying my development team is crazy, okay?
All right.
Because you know
Okay.
what? I have three teams. I have a Windows team, I have a Unix team, I have a Linux team. You know what? And every time they come up with different projects, they come up with small projects. They make the small application, they make the small application, and next year they make another application. And every time they create a development machine, you know what? They ask me to buy the newest server. And so I buy them a new server for their development. So I ask a budget from my CEO. Then we buy the servers, we have them developed. Then afterwards, after they've migrated into production, next year they have a new project. They want to buy another new server. And they can't use the old server. And they say, I can't use the old server. It's too old. And they can't even use the other person's server because it's on a different platform. So it's really difficult for me to keep on buying these new servers, and it's becoming a pile of junk in our data center. So what should I do then?
Yeah, so I think most of you share a common problem with Wendell, no? But not as crazy as him. All right, so you have a lot of machines, several spec requirements, and that's only good for about 6 months. And then after 6 months, you have a new requirement. And what are you going to do with this old hardware,
Yeah.
right? So they all pile up in the inventory. For private cloud solution, one good thing about it is we can lessen the server footprint, meaning lessen the number of physical servers. And how do we do that? Using a hypervisor. So hypervisor houses a virtualized environment. So meaning you have one physical server, right? And out of that one physical server, you run your hypervisor, and that hypervisor can create multiple virtual machines. All right? So these virtual machines could actually be of different operating system. So
Really?
in this slide, we have the Linux operating system, we have the Unix operating system, and Windows. So let me give you some demo on this one.
Wow,
So,
you have a demo there?
yeah.
Wow.
So this laptop of mine, I installed an Oracle VirtualBox. Right. So Oracle VirtualBox is a software that you can just download from OTN and you can run it in your laptop. Right. So just to give you a demo on how virtualization works. Now for this Oracle VirtualBox Manager, you can actually create multiple virtual machines. So here, for instance, I created 3 Linux machines, which I'm going to use later on for my demo, all right?
Mhm.
And then Windows 2003 server. So example, if I need to provision a machine, okay? So you just click a new machine probably, and then name this one as Win Server 3, for example, or 5. Right? So you choose the operating system. Let's say I'm going to use Microsoft Windows, and I'm going to use Windows 2003 and a 64-bit scenario. And then you specify memory and all that. You just follow on the wizard, all right? So you put on your selection, and there you go, right? So you specify your internal storage or local storage, and then you have your virtual machine. Right?
That's my new server?
Yeah, so that's your new server, so you can boot it up and you can install the appropriate operating system for that server. Now, you have multiple servers of that one, and then after, say, a certain period of time that you don't need it, you just have to remove that virtual machine, all right?
So I don't pile up junk in my data
Right, so
center.
you only have one physical server and multiple virtual machines. So you lessen your server footprint, meaning you utilize power efficiently. You don't need additional space in your data center. All right. So just a quick look on how each virtual machine looks like. So we have 3. In my example, I have 3 Linux machines. So I've actually started it up. So this is how one of my virtual machine looks like. Right. All right. So and this is another virtual machine, Rack Node 1. All right, so this is another virtual machine and all that, so which I'm going to use later on for my demo.
Wow, that's great. So, Dan, you mean I don't have to keep on buying new servers each time my development team asks for one?
Right, so when you buy servers, I mean, it will take time, right? And then if you decommission servers, you probably end up with a lot of hardware or a lot of spares. So the good thing about the virtualization is you can provision quickly and you can decommission quickly as well without added cost.
Wow, that's great. So that's for a private cloud setup, right?
All right.
All right. But then that is only the tip of the iceberg. What's worse, you know what, is when these guys go into production. You know what? The day when they start, go live. And the reason for that is that, you know what, my production environments, of course, we use up space. We use up hard disk space. So every year, I sit down with my team and say, okay, guys, what amount of hard disk do you need for our production environments? And they all give me estimates. Well, some are good, some are bad, some are really, really bad. You know what? And of course, I would ask for that budget from my management, from my CEO, from my CIO, and ask for an approval, and I get an approval, and I buy hard disk. Problem is, of course, with their bad estimates, my Linux team has good estimates. The Unix team does a bad estimate, and the Windows team doesn't even scratch the surface of their hard disk. So what I end up with, my Unix team asking for more disks when I can't ask for any more because I can only ask once a year. And my Windows teams, I cannot donate the hard disk from my Windows teams to my Unix teams because it's in RAID 5. So what do I do then?
Right. So space is a premium. You pay a lot for space, and you want to make sure that you get your money's worth or your buck's worth for that space, right? So here an example is the Unix team and Windows team not utilizing the amount of space that they should be or they forecasted. Whereas Unix team is also in danger of losing their services because they don't have any more space. So what is a private cloud solution for that? So in a private cloud solution, you can actually implement a shared storage model. So in a consolidated storage environment, you have a common infrastructure for your shared storage, okay? And then this shared storage and these servers that you have, multiple servers, can attach themselves to this common storage, all right? So you only have, meaning that if this is your Linux environment probably, and they're not utilizing most of the space, the remaining space can still be used by other servers, which is also attached to a common storage. Now to give you an example for that, or to give you a demo, so here I have my three servers, and the OpenFiler, I installed this one. This is just an open source storage server. Okay, I use that as a common storage for my rack, for my 2-node rack. All right, so here we have rack node 1, rack node 2 attaching themselves to a common storage. Now let me show you how the common storage is configured. All right, so here we have the OpenFiler. In a common storage, you have something like a volume group. Okay, so we also have a physical volume, right? And then you group these physical volumes to a volume group. And then from that volume group, you can subdivide the volume groups to logical volumes. Okay. So here we have 3 logical volumes, right, in a common volume group. So and then once you have that configured, you can actually create target system. So here I use ISCSI interface. Okay, so this is my node. You have the ISCSI interface for which my rack 1 and rack 2 connects to the common storage. All right, so we have this. You specify the connections. You specify the IP address, for example. So you have ISCSI targets, and you can look at the network access list, and you will see here that I have 2 nodes given access to my shared storage. Now let us actually look at one of the nodes here and probably give you an idea on how this is configured, right?
Okay.
All right, so my node, you can actually query some of the mount points which are not, appears to be local to my machine, but they're actually mounted remotely.
I see.
So I have this SDC1 mount point, which is actually attached to a remote storage. So once I have this configured, what I actually did for my demo is to use these mount points as for my ASM disks. So ASM is Oracle automatic storage manager, so which I'm also going to use later on. Okay?
Okay, so
So
you
the
mean,
good thing about having a common storage is that aside from utilizing or maximizing your storage, you can use that for your business continuity volume architecture, right? So you can have a common storage and you have a primary server and you have a failover server, right? So initially the common storage is attached to a primary server. When the primary server goes down, it reattaches itself to the failover server. So you have a failover scenario. Okay, so another implementation for that one would be you have your primary server, you attach the common storage to the primary server, you create a mirror, you mirror that volume, and you attach it to your backup server so you can run the backup while not eating up resources in your primary server. So there's a lot of things that you can do when you have a shared storage architecture.
okay, so then that means for my team, I could start my year with everyone getting a certain amount of disk. I mean, not too big. Then, as they need more disks, I could just ask them from you.
Right. So as a vendor, as a private cloud vendor, you initially start with a certain number of physical disks in your volume group. All right. So as you go along, you can provide more physical disks to your volume group. You can expand your volume group, and you can also decommission some of the physical volumes from your volume group, so you can shrink it back. Okay.
Wow, so that means I won't have any team asking me for more space in the middle of the year and me not being able to provide them because of lack of disks. And at the same time, I won't have a team that has too much space because they haven't really used it.
Right. So you can, the good thing about it is whenever you need it, you can easily provision it at a short period of time as compared to buying a new hardware.
Oh, that's great. That will be great for my team. That will work, definitely. Now, and again, but of course, again, that's the middle part of the iceberg. Okay, it's not the tip, but the middle part now. But the bigger thing, which is underneath my nightmares, you know what? Who are supporting production environments here? Or raise your hands. Production environments? All right. So if you're all right, you're raising your hands. Okay. So if you're
these are the folks that do not sleep.
yes,
24
just
by
like
7
me. I
folks.
haven't slept since last night, and like Nilo has not slept for some time. And if you're supporting in production environments, it's really crazy. You know why? Because you could have various systems having different loads, and the thing is that they have different loads throughout the year, right? And my worst nightmare is, Christmas. And it's not because of my pamangkins who come to me and ask for their gifts, no? It's not about that. I'm talking about the workload that happens in my production environment and all the calls I get because of the problems I have with that. So I have a CRM that basically is flat throughout the year, but when it comes to Christmas, boom, everyone uses that system. Then I have a data warehousing system. Basically, it's also flat. Christmas is flat. But right after Christmas, all the reporting comes in and boom, I have a big problem. My system goes down because of the load. And basically, I also have another ERP. I have an ERP system that basically has a bigger quite of load, but is quite steady throughout the year. So I cannot start swapping servers in the middle of Christmas, right? And say, my CRM needs more power, so I'll grab it from the ERP. So, and then afterwards, put it into their data warehousing. That is not possible. So what do I do with the situation then?
Right. Imagine if you're designing your system, right? If you're designing your CRM on a worst case scenario, right, to handle the peak, imagine how much resources are wasted from March to December, because you're basically using it or maximizing your resources only in December. So the same story goes with your data warehouse. If you created a system designed for this peak, then all throughout the year, except for March, you're wasting a lot of resources.
Right.
Okay? So nice to have is ERP, wherein you have a consistent workload. So one of the approaches for in a private cloud solution is to use a clustered environment. Okay? So a clustered environment is actually, for this case, we're actually using Oracle's RAC, Real Application Cluster, right? So you have two nodes, you have two physical nodes, which actually behaves as if they're one. Okay, so you have two physical nodes, and then because they're one, and you can have your applications sitting on each node. For example, if this is September, right? So probably your ERP database will be running on node 1 and node 2. So you have a load balancer in place to distribute transaction for ERP and across node 1 and node 2. And then probably for your data warehouse could only be running on node 1, and your CRM could only be running on node 2. Now come December, probably that would interchange. So you have your CRM load balanced on both rack node 1 and rack node 2, and ERP probably is sitting just in one node, right?
Got it.
Let me take it a step more. So you can actually, instead of using a common clustered environment, you can actually consolidate your database. What does it mean? It means that you can have one huge database to house data from multiple applications.
Wow, I haven't heard of that.
Wow.
Yeah.
Right, so you have your Oracle Real Application Cluster, so running on Node 1 and Node 2. So your database is actually load balanced or running both on Node 1 and Node 2. And you have services in place. Yeah? So you have your data warehouse service, your ERP service, and your CRM service. Now, you don't have to worry where CRM has to run, on which node CRM has to run, or which node database has to run, because they are already consolidated in one database. So you maximize your resource not just on December, you maximize your database resources not just on March, but all throughout the year.
Wow, that sounds too good to be true. Do you have a demo?
Yeah, exactly. So we have a demo here. Actually, I have let me go to I installed using virtual machines, I installed a rack database. It says 11G release 2 real application cluster. As actually, this is the console, how it looks like. And then you can actually see that this rack database has two nodes running, rack DB1 and rack DB2. All right. So with this, I can actually regulate connection using services. So here you have a cluster managed database services. So you have a common database, right? And on top of this database are three services. So here, my CRM service is running on rack DB2. My data warehouse service is running on rack DB1. My ERP service is running on both in rack DB1 and rack DB2. Right? So one good thing about implementing services is you can regulate consumption. For example, I need to regulate CRM users on how much resources they can use for a specific instance. So what I created here is consumer group mapping. So in each service, you have a CRM service mapped to a consumer group. You have your data warehouse service mapped to a data warehouse consumer group, as well as your ERP. Now, once you have mapped these services to a specific consumer group, you can actually create a resource plan, right? So in resource plan, you can budget your resources across several consumer groups, all right? So you have a CRM consumer group. For this particular plan, I say 50% priority 1 of my CPU is allocated to ERP consumer group for that particular plan. And for priority 2, you have 20% of priority 2 for CRM consumer group and 20% priority 3 for data warehouse and so on. And then there's some other policies that you can create for your plan. For example, for each consumer group, you can specify the maximum degree of parallelism for each application. You can also specify threshold in terms of execution time. So they can jump from one consumer group to the other based on how they behave. Now, let me go through more on this. So if you look at how it is configured, right? So you see here, my CRM is running on rack DB2, data warehouse service is running on rack DB1, and ERP is load balanced between 1 and 2, all right? So now if I'm going to connect to my, I'm going to show you the password. just for discussion purposes, okay? Don't do this in
Don't
production.
do this at home.
Okay, so if I'm going to connect on CRM application, right? I just specify the TNS name, CRM, right? So it connects to CRM service. If you look at the connection data, you see here that CRM is running on RackDB2. When I connect to my CRM service, I'm automatically connected to RackDB2. Okay, so let's say if I'm going to connect to data warehouse instead, right? So you will see that. Okay, so you will see here that I'm connected to RackDB1.
Okay.
Okay, so not just maximizing resources, Wendell, right? So because you have run this your application and services, and the database is common, and meaning it's running on Node 1 and it's also running on Node 2, you can actually create high availability.
Really?
Okay, so what I'm going to show you is what if I'm connected to the data warehouse service and my Node 2 database crashed. So what will happen to me? Okay, so let's have a demo on that one.
Don't do this at home.
Okay, so don't do this in production.
Don't do this in production.
Okay. All right.
Don't try this in production.
This is Rack Node 2, right? Okay. All right. So I'm connecting from Node 1. Okay. So this is Rack Node 1. You can see that here. It's in the screen. So I'm assuming I'm going to connect to CRM. Okay.
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 Okay. So I'm connected to RackDB2.
Right.
Okay. So then I go to my RackDB2. Okay. Rack Node 2. Okay. And then I'm going to crash this database. Okay.
All right.
So I'm teaching you now how to crash a database.
You're an expert on this, right?
So that's easy. You just have to shut down abort.
Okay.
Okay. That's a common command.
Okay.
For those who are impatient in shutting down their database, you just have to crash your database then.
Right.
Okay. So my Node 2 is now crashed. Okay. And then I'm going back to Node 1. Okay. So where I'm connected to RackDB2, and if I'm going to look at my connection, okay. Okay. Just type this one. Okay.
Wow.
So
That's
that
great.
is transparent.
Yeah.
So that's what we call as transparent failover architecture. So you are connected to Rack Node 2, right? And then Rack Node 2 crashes, you're automatically failed over to Rack Node 1 without having to exit or to crash your session. So that is transparent failover architecture. And that is that feature is enjoyed only on 11G real application cluster. And then if you have a database consolidation, you're not just maximizing your resources, you're also increasing high availability of your services.
Well, that's great. So my question is, I guess, what if not only for some reason suddenly my data warehouse is not going to use up so much resources on right after Christmas? Will I still be able to maximize the server when it's actually planned for that?
Right. It's actually a good question. So if your data warehouse is not maximizing the database uses, the database resources, then the ERP and CRM can enjoy those resources as well. So they get to enjoy more resources that the data warehouse is not using. So regardless of your application, regardless of your services, you can have access to the unutilized resources. So in that scenario, you are actually eliminating idle resources. So all resources are used up, all resources are shared across services.
Well, that's great.
Right.
That would be great. Now,
Okay.
Okay.
Let me just go through some
Yeah.
of the slides.
now, just a question. So you've presented to me server consolidation, then storage consolidation, then there's rack and database consolidation. Honestly, again, as a conservative development team lead, I'd probably go for the easiest, the server consolidation. Could I just stick to that? Because the other stuff, everything you present is too high tech for me. I'd
Right.
rather stick to the simple ones.
Right. So then again, for each model, for each consolidation model, you have different benefits. Okay. And now this particular slide shows you that as you consolidate if you go from server consolidation to database consolidation, you increase your return of investment. So you get more of your money.
Why
right?
is that?
Why? Because with database, the more you consolidate, okay, the more you reuse services. Okay, so no idle services. You eliminate the idle services. You increase the availability, as
Yeah.
done in my demo a while ago. You have flexibility in handling different peaks and valleys of your across applications. So you have flexibility in handling varying workload requirements.
And I guess, Dan, one thing I noticed that as you progress is that each technology was actually sitting on top of the other one.
Right. So you have server consolidation, and then you can have storage consolidation on top of that. You can have a cluster consolidation on top of yours, together with your storage consolidation, and you can have your database consolidation on top of your cluster consolidation as well. Right.
All right. So that makes it more efficient, I would say, right?
Right. So here, actually, my last slide. This is a summary of different different considerations when you decide for a particular model, right? So there are factors like implementation and return of investment. Just to give you some highlights, you mentioned a while ago for server consolidation, it's easy to implement server consolidation, but return of investment is low compared to the other consolidation model. Whereas database consolidation is pretty much complex to implement, but you enjoy the highest return of investment.
Wow. Okay. So you got me. I'll go for database consolidation.
Right.
Right. So again, my question is the cloud scalable then?
Definitely. So you can actually scale up and scale down your infrastructure with the highest cost efficiency and effectiveness. Thank
Okay.
you, everyone.
Thank you,
for
everyone. That's
listening
it.
to our discussion.
We were acting, by the way, if you didn't notice. I'm not a development team lead.